This training video will use Civil 3D 2018. This is going to be the Maryland training session number 4, and I'll be going over surfaces. What is a surface? Surface is a three-dimensional geometric representation of an area of land, or in the case of volume surfaces, is a difference or composite between two surface areas. So you can have an existing ground, proposed ground, and an as-built ground, and you can compare all the surfaces with the volumes. So surfaces are very complex. They're made up of triangles or grids, which are created when Civil 3D connects the points that make up the surface data. To use a surface in your drawing, you can create an empty surface and then add data to it. You can also import existing files containing surface information, such as land XML, a TIN file, or DEM files. Points or contours are usually a primary part of the original surface information and are supplemented with break lines and boundaries. So we'll go over a little bit of the break lines and boundaries. Boundaries define the visible area of a surface. Only the area within the boundary is included in calculations, such as for total area and volume. So that's very important when you do your cut fills, that you create a boundary so it doesn't calculate volumes outside of that boundary. You can also define masks to hide or show parts of surface for editing or presentation purposes while still including that area in calculations. Another feature we'll go over are break lines, which are used on tin surfaces to define linear features that triangles cannot cross, such as retaining walls or streams or center lines as drainage swales. Break lines affect triangulation of the surface, so it gives you a more accurate representation of the surface that was surveyed. So we'll go a little bit over creating and adding data to a surface. So when you create a surface, basically there's 3 surfaces built into the templates. In the Prospector tab, you'll go to Surfaces, and if you expand that, you'll have As-Built, Existing Ground, and Proposed Surface. Pretty self-explanatory. Existing ground, that's the surface that basically all your existing ground survey is brought into in that surface. Proposed is the surface that you'll create for your proposed ground. And then you have as-built, which is your completed work. And after the data has been added to a surface, it becomes visible in the drawing in accordance with the display settings specified in the reference surface style. And you'll see once we get into Civil 3D, when you bring in that points and it creates a surface, you'll see the actual contour lines, they'll be generated into a specific style that was created in the template itself. Tin surfaces basically composed of triangles that form a triangulated irregular network. A tin line is one of the lines that makes up the surface triangulation. So if you ever had the chance to actually create contour lines, triangulation, so when we used to hand draft, you actually had to take the points, divide the 2 points, actually it would be 3, triangulation, and you'd have to get the average between each of those elevations, and that's where you would draw your contour lines in between there. Well, the beauty of Civil 3D, it does all this automatic. So it's nice having to know where that information comes from. So when you have multiple points, so the more points you have, it's going to be more accurate because you have more triangulation lines that are going to connect to those points and give you better averages in between those elevation differences. Boundaries, as we explained before, is basically the area that you want to, if you want to shrink it down, if you go out and do a survey and you want to shrink that area down to a smaller area, you can create a boundary. Or if you just wanted to select a boundary for cuts and fills, just have to make sure that you select that boundary, and you can create that boundary and name it whatever you want within that surface. So for example, in this surface we have a boundary, we've created one, and we can name it whatever we want. We can say outside survey area. Boundaries are very useful in the cut and fill command also. Another useful tool, break lines. Break lines define the linear surface features such as retaining walls, curbs, tops of ridges, and streams. What they do is force surface triangulation to run along the break line. Triangles do not cross a break line. So if you go out and do a survey and you get a center line of ditch, but you don't get top of bank or on either side of that center line of swale, and your topo lines are just not showing that in there as a swale as it should be shown, you can make that connect all your center line of ditches points and make that into a break line, so to give you a line that will represent the flow of that existing ground. So how do we create a surface? The first thing you have to do is have points. Go out and survey, and if you go back to training session number 3, I go over all the points and how to import the points and manage the points. So I'm not going to explain that in this training, but basically what you're going to do is you're going to have your points in there, bring your points in, and go ahead and update those points. And it's going to actually show your contours. So we'll go ahead and open up Civil 3D and bring our points in and show the contours. Okay, so we have our prospector here. We have our points in. Right now they have the exclamation point, meaning that they're not showing. Go ahead and update that. Right-click Update. Right-click All Points. And we can go ahead and zoom to. And now you'll notice that it's created our topo from our points. Change the scale to 1 to 20. You can see the points come in. And you'll notice this is a little bit different than that's on the actual handouts. This is the updated templates that I'm using. So it might look a little bit different than what the actual handout is. So once you bring your points in, you update those points. Now you have your surface that basically has been created. And if you go in the prospector, you'll see here point groups. It's coming from the existing ground. And going back to training 3, if there was points that you wanted to take out of that existing ground so it didn't interfere with your actual surface, you can go in and manipulate that point group. So just some things to keep in mind. I change the scale 1 inch equals 20. And that's just basically my view. If that comes in at 1 to 1, you can barely see the points. So just by changing the scale, 1 inch equals 20, points are now shown. And then one nice thing with surfaces, if you just hover anywhere over that surface, it'll give you the real elevation of that surface based off of your survey. So it's nice if you're trying to show something to a landowner or even a colleague in the office trying to go over something. If you hover over that surface, and if you have multiple surfaces, cuts and fills, or even proposed, it'll show all those surfaces on that screen, so you can get a real-time update and see exactly what's going on in that design. So it's nice seeing that. A little bit about the surface properties. In the existing ground, go to surface properties, and you'll see the name and the surface style, existing contours 1 and 5, and then you can change that to whatever you want as far as the style. The default is existing contours 1 to 5. So if you go into your surfaces, your existing ground, right-click, surface properties, existing ground, existing contours. So if you want to do no display, you can do that, or you can do existing contours with different elevation. One nice thing, if you go into statistics tab all the way to the right, and if you go to general, it tells you how many points you have, the minimum elevation, the maximum elevation, the mean elevation. And then if you click on the 10, this will give you the number of triangles that are actually in that surface. And then the extended 2D surface area to 3D surface area, minimum grade and slope, maximum grade and slope, and then the mean grade. Now, sometimes you can get the average and use the mean grid on this, but you'll notice that the maximum is 194%. So it's taking consideration, something that's happening down in here that's falling off, and it's averaging that. So if you wanted to do an average over, an area, if you will, you could put a boundary on there, of that area, and then go ahead and get your average on that. So you can take that out, by putting your boundary on there, and it'll give you different statistics for that. So just keep in mind when you look at these, I mean, it's used for reference, but you can, go into that tab and see some of the stuff that it does give you as far as the surface is concerned. So that's where you would go in and change any of the surface properties to what you want. So as I stated, on the left-hand side here, you'll see the existing contours at 1 and 5. And then if we changed it, the existing contours 0.5 and 2.5. So that's a half a foot to 2.5 foot. So your minors are every half a foot, and your majors are 2.5 foot. Whereas this one was minors 1 foot, majors 5 foot. So you can change that on the fly as you're designing, as your final design. Just make sure you can, just be aware that you can change those styles of the contours. And it's based off of the surfaces, so it'll change on each surface that you want. Contour labels. There's 3 different types as far as labeling contours. Single, multiple, and multiple contour labels at an interval. Single is pretty self-explanatory. You basically select the contour label that you want to add a single contour label to on the surface. Multiple contour labels, you can create contour labels by specifying line segments that cross contour lines of a surface. So they'll be right in line of a line that you draw. And then multiple contour labels at an interval, you can select multiple labels, contour labels to a surface at a specified interval. So how do we do our labels on our contours? A couple ways of doing it. You can go ahead and right click existing contours, add label, and what it does is bring up a feature. Click the surface, and from the drop down, go ahead and click contours, and then you hit the label type. There's different label types that are out there, and we'll go over that. Contours are your proposed, and then there's an existing contour style that we'll use for existing contour labels. So we'll go into that real quick. So contour labels, you can go up to annotate, add labels, surface. You can add surface labels this way: spot elevation, slope, contour, single, multiple at interval. Or you can select this little tag, and it brings up a little window also where you select a feature. In this case, it would be surface, and the contour single. And then, as explained before, contour elevations, label style is proposed ground. Existing contour elevation is existing contour ground. So in this case, we would choose the existing contour elevation. Images and no masking. So if you do have an image, it'll actually do a mask around it. And if you do no masking, it won't have a mask around it. And then this here is just your traditional one that goes on top of your contour line. So if you selected that, you can go into the Edit tab, for example. It'll tell you exactly all your different, how it's laid out. So all your properties and label style, the behaviors, when it was created, So it kind of gives you all the information right here. And I think I went over this a little bit in the points. So it's kind of the same process. You have some type of style, and if you wanted to adjust that style, you have to get down pretty deep into the program to, change those different style settings uh, within that uh, label style. So you would select all existing contour elevations. So to add the contour label single, go ahead, hit add, select your surface, select the contour line, and then select the next line, so on and so forth. Hit enter to end the command. Now, if I were to select images, go ahead, and you'll see I'm selecting all these the same. So that's major contour label style, minor, and user control label contour label style. I just keep them all the same, but if you wanted a major different than a minor, this is how you would do it by selecting the different styles. Click add again, select the surface. If I do no masking and then add it, select my layer, my surface. Here's my no masking. And what you'll notice here, if you do no masking, it puts it over top of the actual contour line. And you'll notice the one with just existing contour elevation, it actually breaks that contour line. And it, gives you, it kind of shows a mask around there, but it's actually breaking that contour line. Is one better than the other? It's all in your preference. But I will tell you that if you're doing an actual elevation that you want to see, over top of a existing photo or image, then I would do the masking one, because that way it would show up. It would actually put a little mask around that, and it'll, it'll be like a white background, and it'll show up over top of that photo. So with that being said, you don't want to put your contour lines over things that are going to be relative to that image that you want to see, because it will have a mask around it. So keep that in mind. But you can move them. So if you accidentally put them somewhere in the image, you can move those contours. What it does, it takes a contour label that is just one single label, and if I select the top, it now will create it into a line. And I can adjust that wherever I want. But notice if I try to move this now, if I select on one contour line, it moves the entire contours as a group because they're on that line. So if you don't want that to happen, then you bring this back down to where you were on that specific contour. And you'll notice it. So now I have my line back to where it was. So that's contour elevation label. So you have a lot of options with that. And again, you can do add labels from the annotate tab. That's the easiest way that I see, adding your contour labels. And again, you can do an add label here under the surface. So if you just right click on your existing ground, add label, it already gives you that you're on the surface. So you can come through it this way also. So there's a couple ways that you can do it. So as far as the existing contours are concerned, what I want to show now is putting in a break line, going over the break line, boundaries, I'm kind of showing you what the triangulation looks like. So if we go into the existing ground surface properties, and again, information, if you go to triangles, click apply, you'll notice here, this is all the different triangles that it is creating the surface from. So like I explained earlier, is that you have an elevation of 106 to 102, and what it does, it in between this line, so you take these 3 points, it's triangulating the elevation between here, between these two, and between these two, and then it'll average them, and then your contours will be drawn, where they should be in between 106 and 103, and 106 and 102, and 102 and 103. So that's how Civil 3D generates these contour lines by triangulation method. So we'll go back to existing contours, 1 and 5, click apply. Break lines. So in this design here, you can kind of see there is a swale. It says ground shot, but it does, show a little bit of a swale there. Another one here is a ground shot, shows a little bit of a swale. But if you really wanted to, take that elevation and, say, or take that swale and start here and you wanted to go down to here, what you could do is on the existing ground, make sure you're on the existing ground. But if you go up to the Home tab, and actually the best way to do it is go into here, existing break lines, so EX break lines. Or if you use tool palettes, some people use the tool palette, some people don't. So if you come over here to base map and existing features, if you hit this button, surface break line, and this is a tool palette, and you come over here, it automatically specifies a start point for the polyline. Turn on my OSnap, and as I'm drawing this, you'll notice that it'll put it on the existing break line, layer. So you don't have to have this current. But if you wanted to do another break line, draw a polyline, just type in polyline and draw in a line. So I'm on the existing break line layer. And let's say, just end here and hit enter. So right now we have 2 lines drawn. One was done with the surface break line command, and one was just drawn as a 2D polyline. So a break line is actually a 3D polyline. So what we need to do is come into your existing ground, expand that definition, and if you go down to the second one, break lines, right click, add, and you can have multiple names for multiple break lines. If you had 10 center line of ditches, you can just call center line of ditch, select all those break lines. But if you wanted to break them up, you could do so. But in this case, we'll just call it CLD, center line of ditch. I'll do 1. Keep everything the same, but you do have standard proximity wall from file non-destructive. Standard is the one that I use the most. Sometimes I'll do a wall if it's actually an actual wall. So in other words, if the actual break line will stop, so nothing will go beyond that break line as far as triangulation is concerned. So there's a wall there, so it might be a 10-foot high wall. It'll stop, and then the contours will then start on the bottom. So it'll almost be like a separate surface, by putting in a wall there. So standard is the most common one. I keep everything the same here. Go ahead and click OK. So in this case, I'm going to select the break line that was created first. Click enter. And you'll notice not much happened on this, but a lot of times if you have a big change, you'll see this, these contours change a little bit more drastic than what it did there, which didn't change that much. So now we have that center line of break line. You can zoom to it. It's going to show you exactly where it's at. You can delete it. So we're going to create a new one, right click add, and we'll just call it centerline edge 2. Click OK. Now we're going to select this break line, click enter. So now we have two break lines that have been created in this drawing. So the next thing we'll do, and we can turn these off for now. The other thing we can do is create a boundary. So again, a couple ways of doing it. If you go into your palettes, if you have them loaded, general drafting, they call it borders and boundaries. They have two of them, but you'll see a border is a 2D polyline placed on a border, and then this is a 2D polyline placed on one boundary. So if I select this and I created a new boundary, I just go out the outside here. Go ahead and close it. There's my boundary that I created. Another way of doing it is just going on the one boundary layer, making sure that's current. Draw a polyline in. Hit C for close. So now we have two boundaries drawn. Again, definition, expand on your existing ground surface. You'll see boundaries is the first one. Right click add. You can call it, whatever you want, lower. So there's different types. There's outer, show, hide, and data clip. So once you select it, the outer will be basically clipped out if you select outer. So once you select that boundary, the outer will be clipped. Show, you're just showing everything. Hide, it will hide everything inside of that boundary and everything shown outside of that boundary. Data clip, I'm not sure what that does. I've tried doing that a couple different times, like with buildings and things like that, and I don't really see that much change with the data clip. So basically the two that I show are the outer show and outer show and hide. So we'll do the outer first. Go ahead and non-destructive. So keep everything default, click OK. Select the boundary, and you'll notice that it basically takes everything out except within that boundary. So if I select over top of that, it tells me existing ground. If I go outside of that line, you'll notice that there's no data associated with that. Or if I go in here, there's nothing coming up. It's only the data within that boundary that the surface is generated from. So if you go back to your existing ground, surface properties, in that boundary now, here's the number of points that are associated with it, the minimum elevation, the maximum elevation, and the mean. If you go to the extended, now the minimum grade is 0.5, the maximum grade is 7.8, and the average is 4.67. So as I explained before, if you wanted to do an actual area, if it's a watershed that you brought in from LiDAR or something like that, you can create a boundary of that watershed and get a general mean slope over that area to help with your watershed is one way that I see doing this being useful, making a boundary. So just know that it's out there. So you have that boundary. So one has been created. And if you select it, it says lower. And you can delete it. You can zoom to it again. So we'll go ahead and we'll just delete that boundary. And it'll bring everything back. So add We'll say upper, and we're going to hide. So we're going to hide the information that's inside and hit enter. So it hides that information. And again, if you select over top of it, nothing in there, go outside of it, it shows you there's information in there. So you'll notice with this one, you can actually add multiple. So if I hit delete, add boundary, upper, lower, hide. So you select it, it's highlighted, and we can select another one, hit enter. So it's just hiding the information and showing the actual topo outside. But you'll notice that it doesn't, that information, even though I hover over top of it, it's not giving me elevation. That contour line is still, going through that area, but it's just not giving any information on it. So what I like to use this one on is if you have like maybe existing concrete or something that you don't want to show contour lines on, or if you have an existing building that you don't want to show contour lines going through, existing contour lines going through, that's when I would use the hide command for the boundary. And again, like I said, boundaries are very important when it comes to cuts and fills, because when you give that outside boundary, that's where it's going to stop for your cuts and your fills for the analysis to get you the correct numbers. So just keep in mind that boundaries are very useful tool as far as the existing surfaces, proposed surfaces. Same way with the break lines. They're tools for you as the user when you're making sure that you're creating the best surface to begin the drawing with. And just keep in mind that existing ground is probably the most important part of the design. If the existing ground is incorrect, then your whole design can be incorrect. So take time when you're creating boundaries or break lines or even surveying and bringing in the points and making sure everything is correct before moving on to the actual design. So we went over the contour labels. Now we want to go over creating a proposed surface. So creating a proposed surface in Civil 3D, there's many different ways of doing it. I'm going to go over the most basic way to get you a proposed surface. Here in the future, we're going to go over grading tools and creating surfaces that way. So it's going to be a lot different way of doing it. It's a lot more automatic, if you will, by using grading tools. But to get by to using the program, I'm just going to go a little bit over creating a proposed surface this way by adding contour lines. So basically what we've done in Carlson is that you basically create lines, draw lines, and make them into a polyline and add a contour label to them and make them into a contour label. We're going to kind of do the same thing, or contours, making these contours. Feature lines is another way of creating these lines, and feature lines are basically 3D polylines, and you can adjust the elevations throughout that entire feature line length. But that gets more into the grading tools. In this example, in this video, I'm just going to go over the basics of creating a proposed contour using just contour lines. It'll be very generic, and it's way of designing this. So if you have a surface that you want to create that is not on a template, you can go to your surfaces, right click, create surface, and you can basically select all the different things that you want to on that surface. You can name the surface proposed if you want to. Make sure it's a thin surface, surface layer, proposed contour minor or major, whatever you want to use for the surface layer. Again, information, name, proposed, and then the style. FG means future contours, 1 and 5. And then once you create that, go ahead and click OK. And then you're going to isolate those existing contours that you made by typing in lay ISO, and then select those proposed contours. And then what you're going to go into that proposed surface that you made, right click or go down, right click the proposed, go down to definition, expand that, and go to contours, and go ahead and click add. And then you're going to select all those contours that you made. Now, the one thing you have to make sure is that the elevations are set up correctly on those proposed contours. So as you make these polylines, you have to make sure that they're closed polylines, and 2, that they have the correct elevation associated with them and they're tying into the existing ground. Once you select them all, go ahead and click OK. And you'll notice here that it creates a new proposed surface, this purple line. Turn that layer off. And what happens is now, by turning that layer off, you have that drawing that you created with the polylines shown. So it's a little bit nicer, cleaner than what was created through Civil 3D. All right, so you'll notice here my existing contour, or my proposed contours that have been drawn. If you select on those and go to properties, it actually gives you an elevation. And the other thing to keep in mind on the properties is the elevation and making sure that it's closed. Select on that, making sure that it's closed. It says yes. Making sure that your actual polyline is closed. And making sure that they actually have elevations assigned to them. And this is just basic general drafting in Civil 3D. Nothing fancy. Just basically drawing in lines and tying into the existing contour lines, surfaces. So you can kind of see the existing surface tying in to all my different contour lines. So now that we have that done, make that one to 10. We have our proposed contour lines drawn. Now, a couple ways of doing this. I went over in the instructions that you can create your own surface, or you can go in and create or use the proposed surface here. So on this here proposed surface, it has a staking as for your point groups. So anytime you create any points for staking out, it's going to be put in this proposed surface in the point list. So we can just use this proposed surface to add contours. But first off, what we want to do is we want to isolate this layer first. So lay ISO. So now we have that isolated. These are the contours I want to add to this proposed surface. So we go ahead and click contours, add, and we can just call it, proposed. Go and click OK, select everything, hit enter, and now it's selected those contours and created that. Go ahead, you can do rebuild automatically, so it rebuilds it automatically. Unisolate everything, and if you go to surface properties here, information, there's no display set up on that right now, but if I did future contours, 1 and 5, click apply, click OK. You'll notice here that it goes all the way out, as I explained before. So the one thing that you need to do and keep in mind is that you have to do boundaries. So we'll go ahead and create a boundary on this proposed surface. Go ahead and uncheck future ground, click apply, All right, so we're going to have to create a boundary for this. So what I like to do is just polyline, make sure you're on the boundary. Just go outside, as close as you can, to your existing ground, because this is all tying into existing ground that you have shown anyway. Make sure you hit C for close when you're completed. So now we've created that boundary of my proposed surface. Right click add, just say outer, click OK. So now if we go and show this, future contours 1 and 5, click apply, click OK. You'll notice that nothing's shown, everything's shown inside now. So to add the contour labels, come up here, select the one text, type in MT for text, type in an elevation 99.0, copy that, move it to the line. You can rotate it, RO for rotate, RO for rotate. You can move it onto the line, then you can copy that, and then you can move it up here, move it down here, wherever you want to put your contours. So now, if you select your contour, you know that's supposed to be elevation 98. That's supposed to be 90, 100. So that's one way you can do it. That's a workaround. If you want to draw a box around them, you can type in T-circle, select your objects, all your different contour labels that you have, hit enter. Offset distance, you can just keep it 0.35. You can do circles, slots, or rectangles. Variable because it's going to be longer in some of them and shorter in others. Hit enter, and now it draws a box around your contour lines if you want to have a box around there. Just keep in mind when you move this contour now, as you move that contour around, it's not going to move that box with it. So just keep that in mind. You'll have to move that together as one unit. Move it, wherever you want. So that's a crude way of doing it as far as your contour labels are concerned. So the next step I want to go over is the cut and fill calculations. You have to have an existing and proposed surface, or you have to have two surfaces in order to analyze between the two. So in this case, we're going to analyze, an existing ground and our proposed ground. So if you come up to the Analyze tab in Volumes Dashboard, you'll get a little pop-up window, dashboard, that pops up, panorama. You actually have to create a new volume surface. Call it cut and fill, so you're actually creating another surface. And then what it's shown here is a base surface and comparison surface. So existing ground and proposed. Click OK. And it kind of gives you a little bit of graph here. Total cut, total fill. This is the net cut. So it's basically showing red is your cut, green is your fill. And you want to try to get those close to actually showing your cuts and fills. So when you do grading tools, you can actually adjust your cuts and fills, and you can say, you can adjust them basically saying, I want to balance my cuts and fills, and it'll raise and lower elevations to balance your cuts and fills. Whereas what we're doing here, we're just getting, basically an estimate of what we're doing as far as the cuts and fills are concerned. We're not actually trying to adjust the volumes or anything. But it does give you, an estimate on this. A lot better than doing it by hand. As long as you draw that border around, like I said, that's very important. So again, here it's like a actual surface style. So here it's showing no display, gives you the cut and the fill and the net cut and fill, gives you the area. So it gives you some information, but make sure it's on no display. And then what you can do is you can create a PDF, or you can actually insert it into the drawing, whatever you wish to do. But if you do a cut and fill report, I'd recommend printing that out, making it into a PDF, and that will go along with your design drawing. If you hit the text, like I said, this will add it into your drawing as text. If you want it somewhere in your drawing, you can do that. But just make sure you have that specific piece of paper in the text folder, and that somebody actually signs off on that, initials it, and dates it, saying that they reviewed it. So we'll go ahead and take a look at this in Civil 3D. So again, we have our existing and our proposed surfaces, existing and proposed. So again, Analyze tab, Volumes Dashboard. So if you select over this, create new volume surface. 10 volume surface is what we're going to create. Surface layers, existing surface is fine. This is where you name it. So we just call it cut fill. If you wanted the description, you could do that. The base surface is going to be our existing ground. Comparison surface is going to be our proposed surface. Click OK. So it's going to give us a total cut, total fill, and our net cut. So basically, it's saying we have 645 cubic yards of extra material left over in this case. And again, it gives you the style. So if you don't want to show your cuts and fills, you don't have to. You just hit no display, click OK, and it's actually not going to show you on the drawing. But this gives you a nice overview of what's going on. The cuts and fills, this here will create the PDF. It'll actually make an HTML. Select that. And then you can right click and you can print it and save it as a PDF and put that in the folder. Or again, select the text and ask the insertion point, and it puts it in your actual design there also. So again, this is just like another surface. It creates a surface, has surface properties, so you can turn this on whatever you want to. Triangles, no display grid, but we'll do future, and you'll see the cuts and fills come in here, estimating, if you hover over top, proposed. So this is a fill of 2.357, whereas if I went over here, it's a cut 0.8. So it's a very useful tool. And even if you have that turned off, if you hover over top of it, it'll give you cuts and fills based off of what that surface is comparing to. Again, keep in mind with your cuts and fill amounts, wherever this border is, from your proposed surface, it's going to, adjust it based off of that. So with a cut and fill definition, again, you can do a boundary. So if you wanted to only do a certain area, you could say, inner pool. And you can select, that line. So now this is the inner pool. And if you go back to your cuts and fills, volumes dashboard, it's saying I'm cutting 975 cubic yards out of my pool area. So again, that's giving you an estimate of how much cut in that pool area. So you can use boundaries on there also, uh, just to figure out, maybe you need to know how much you need for the berm, and you can do a boundary around the berm to give you an idea. You can do that too. So boundaries, you know, use them to help you out as far as designing is concerned. But once we get into feature lines, grading tools, all this stuff is basically going to be washed. It's totally different in the grading tools and the feature lines and things like that. Because you're tying into an existing surface, you don't have to do boundaries or anything. But, you know, this will give you a good idea of, how to do this, in Civil 3D for now, just to get by. So that's all for this video. The next training session will go over profiles and cross sections, and that'll be training session number 5.